Hi, everybody. Nice to see you here. So you may have seen Ryan introduce Deno in the JSConf Europe last year. And this morning, Ashley gave us a great introduction to Cloudflare workers. It is exciting times, once again, like for innovations in server-side JavaScript runtimes. So here I am going to talk about our recent effort to bring a new set of APIs into Node Core. This may be an opportunity for us to rethink about the JavaScript API surface in the ecosystem and create a more universal developer experience across the different platforms. So let's finish the boring part real quick. Allow me to introduce myself. My name is Joyee. I live in Hangzhou. I work remotely on the compiler team at Igalia. I'm also a member of the Node Technical Steering Committee. You can find me on GitHub or Twitter via the handle Cheung. So some of you may be aware of this effort of bringing more web APIs into Node Core. But maybe some folks here are just curious because the keywords here seems interesting. So in case I am using some lingos that only a very few people understood, so what does it mean when we talk about bringing web APIs into Node Core? Well, we're basically talking about adding browser APIs to the Node.js runtime as buildings so that you can run them on the server side without using npm install. So in this talk, I will try to be objective and summarize how far we have come in this journey, where we are, and where we are going. On a teeny tiny side note, .js part of Node.js is silent. So like many others, I will try to use the correct pronunciation in this talk. So here is a mental picture of how JavaScript in the wild came to be. So in the beginning, before Node came along, there were two kinds of APIs that came with the runtime for JavaScript developers. There were some JavaScript built-ins, like date, regular expressions, errors that were part of the language, standardized by TC39 and implemented by JavaScript engines. There were also host APIs, and at that time, hosts were basically just browsers. These APIs were implemented by the browsers and are more or less standardized by organizations like WWDC or Warwick. And then Node was created and started to take off on the server side. It initially included some of the web APIs that were already present in the browsers, or like at least some APIs that look like what you'll find in browsers. But Node also introduced several different APIs for doing certain things on the server side, like event emitter instead of event target in the browsers, because the semantics of the equivalent APIs on the browser side may not totally make sense for servers. Like, for example, there isn't one down tree in this execution context for events to bubble through on the server side. So it does not really make sense to implement part of the event target specification in Node. So as time goes by, browsers have developed and standardized more APIs in the browser to empower web developers, while Node also developed several equivalent APIs on the server side with a different design. Because of the popularity of the Node.js runtime, these homegrown APIs gradually became the de facto standards for server-side JavaScript runtimes. But obviously, no one likes to remember two sets of APIs for doing basically the same thing. So over the past few years, people have been sending feature requests to Node to bring the two platforms closer together. For Node, it usually means making the runtime more compatible with browsers. So Node did evaluate and implemented some of the requests, and it is still looking into more APIs from the web. So we currently have different types of web APIs implemented in Node Core. So some of them are more lookalikes of the browser ones. For instance, we have methods like setTimeout from the browsers, and this is the living standard of the timers in the one-week HTML specification. In Node, we also have a similar set of timer APIs, but the implementation does not strictly follow what the browsers do. For example, setTimeout in Node returns an object, while browsers usually return a number instead. The other type of web APIs we have in Node Core are the ones implemented with an existing specification in mind and behave mostly the same as the APIs that you will find in browsers. For instance, the new URL specific implementation in Node Core was developed specifically according to the one-week URL standard. This means we did look at the spec test when we implemented them. And we also have tests. So how do we know how close our implementations are to the ones in the browser? We run a subset of the web platform tests, which are tests which shared among browsers and other implementations. So to see the current status of web platform test conformance in Node, you can look at the status files under test.wpt status folder of the Node project. There are a few pretty self-explanatory JSON files documenting the conformance of web standards implemented in Node. So this one is not technically a web API addition, but I want to mention that there is now another type of web standards implemented in Node Core. We have collaborated with the one-week HTML specification, and the first implementation of JSON modules has landed in Node master branch as part of our experimental ECMAScript module loader. So yeah, Node implemented first. So here we have the web APIs implemented in Node Core that can be alternatives to certain homegrown Node built-ins. The legacy methods under the URL and curious string built-in module can be replaced by the new URL and URL search params classes. And certain encoding and decoding methods of buffer and string decoder can be replaced by text decoder and text decoder as well. And there is the performance timeline API, which, for example, can be used to replace certain timing methods in the process object. In addition, we also have some APIs that are not exactly replacements for existing Node APIs, but are similar enough in many use cases that it is reasonable to consider them as alternatives. Be sure to read the documentation if you want to rewrite your code with these APIs. For example, queue microtask can be used to queue a microtask that will be run asynchronously, which can be used to replace process the next tick if you do not have strict requirement about the timing you want your task to be run. There is also web worker, which spawns threads in Node, and it may be used to replace child processes if you are only looking for a way to offload your computation to other CPU cores and you don't necessarily need processes. So as of Node 12, we have several web API implementations that are now stable and can be used in production. Those are listed on the left here. And these are available as globals, so you don't have to require a built-in to get hold of them. These are also covered by the web platform test in Node Core. There may be some additional extensions in these APIs and some minor unspecified behavior differences, but at least those are fairly limited, and we are aware of them. We also have a few APIs that are still experimental, which means there may still be breaking changes in the future. These are currently placed under built-in modules and not on the global object yet. The current experimental web APIs that we have are workers and performance timing API. But they also differ significantly from what you would get from the browsers. And we do not run web platform tests for them yet, so watch out. So there is also an implementation of WebAssembly, the JavaScript API of WebAssembly that we get for free from V8. but although the web API of it has not been implemented yet. Other than existing APIs, there are a bunch of others that are haunting the issue tracker. They are still under active discussion. There are web strings, which are the foundation of many web specifications. But then we already have Node strings in core, which are also the foundation of many existing Node core APIs. In case you didn't know, there are many different types of strings in Node. There's string number 1, which has several issues. So they now introduce string number 2, but then it also has some issues. And then they'll introduce string number 3, which still had issues. So there's now a new implementation of strings called Bob, which is under development for some time, and will hopefully solve all our problems. Anyway, this is not a string talk. You can read the documentation if you want to learn more about them. So with all the strings, you can imagine how complicated it would be to bring yet another string into Node core. And there is also fetch, which is probably the most requested web API in Node core. We just had a session about it this week at the OpenJS Collaboration Summit in Berlin. And there is now a new work in progress pull request to bring fetch into Node core. Yay, fetch! Thank you. So we have talked about the history of these web APIs in Node and what will be coming next. So why exactly are we doing this? One obvious reason is with a common API surface, there is less cognitive burden for developers. We could share documentation, tutorials, tooling, instead of developing and maintaining a separate set of educational resources. This is especially important for JavaScript beginners. At the moment, they have to choose between web APIs and Node APIs when they are just getting started. With a common API surface, beginners can be less distracted when they're just learning about the basics. There are still differences between the two platforms, but it will be less intimidating when they already learned a bit more about these APIs. So another reason for adding the web APIs into Node core is that we simply have more maintainers compared to most NPM modules. This is open source, and it's natural that contributors come and go. In Node, even when the existing maintainers of a specific built-in module show up less often, we have an open governance and an effective nomination and onboarding process to bring new contributors into the team. Compared to regular NPM modules, this kind of maintenance story fits better with the web APIs that are designed as built-ins for the host environment. So if you have been paying some attention to this topic, you may be aware that it takes an extraordinary amount of time for these API additions to actually be accepted into Node core. So here I will lay out some of the reasons why there are several requests that keep showing up in the issue tracker but have never really gone anywhere. So everything I'm going to talk about later are in the context of the consensus-seeking model of Node core. So Node core is operated under the consensus from over 100 core collaborators. These are contributors who have write access to the repository. For every technical decision, any one of these more than 100 Node core collaborators could raise an objection. If consensus cannot be reached within the collaborators, it may come down to a vote among the members of the technical steering committee, who are a subset of the collaborators. But we usually try to avoid voting. We also take community feedback into account, even if it's not from someone who have committed into Node before. So here are the common arguments against adding web APIs into Node core. There is still, to some extent, a small core philosophy within Node core. It's about providing only the basic functionalities in core and empower users to implement user-land modules instead of building our own opinionated APIs that may become compatibility or maintenance burden. This philosophy has been broken several times in the past, but at least far as web API goes, we are still mostly just trying to expose the existing functionalities through a different API services. This is not exactly an idea that's welcomed by everybody either, especially when the web API may also lack features that do not make sense for browsers. Oh, yeah, and like sometimes they may be necessary for servers. So one alternative to adding these APIs in Node is to release them as official modules. Theoretically, for modules that are maintained under the Node organization, it would be possible to have a maintenance story similar to the one that Node Core has. But some may also argue that it is easier to optimize an implementation if it's done in core, because it can use certain internal APIs. Or sometimes it may just not be technically possible to implement something without access to internals. Apart from the philosophical concerns, there are also concerns about the design of the web APIs, because they're more than just a bunch of interfaces. Behind the design of these APIs, there is just a very different context. For instance, the browser has a very different security model. When you fetch an API endpoint, for example, at bar.com, for a script living in food.com, and you want to send credentials like cookies along with the request, fetch as implemented according to the specifications should follow the cross-origin resource sharing protocol and check the access control allow origin header in the HTTP response before invoking the callbacks with the data, so that untrusted scripts cannot steal your cookies when your server is not aware of them. So somewhere in Node, there isn't really a concept of origins, at least for now. So these scripts are loaded from your local file system and are just trusted by default within current security model of Node. If you perform the request using the existing HTTP.request method in Node, this security policy would have to be implemented by the users. Well, if they do want them. It is not impossible to implement something like this in Node, but this may just be confusing for most users, because then we'll have two conflicting security models in Node. So when we look at the fetch specification, the interface itself is just the tip of the iceberg. There are many implications under the surface of the JavaScript API, like cross-origin resource sharing, content security policy, caching, interop with service workers, and like credential management. So some of these may make sense for Node, some of them don't. If we only implement part of the API that we think makes sense for Node, we may confuse our users more, because this will bring another kind of platform compatibility headache to everyone. There is also another type of concerns. The ecosystem has already come to depend on a lot of existing infrastructure in Node, and this may differ significantly from their web equivalents. For example, we have different interfaces to do streaming and to emit events. As usual, there are even more differences in the underlying design of these infrastructures. When implementing web APIs in Node, we also need to decide whether we want to introduce the web infrastructure into Node Core or base the higher level APIs on the existing Node infrastructure, or just use some abstraction layer instead. We will also need to figure out the interop between these abstractions for other existing modules, and this work just takes a lot of time. So there are a lot of open questions to answer, a lot of decisions to be made, and this just takes time in the current consensus-seeking model in Node Core. But how do new web API actually ended up being added to Node Core these days? Usually starts with a feature request opened in the Node.js/Node repository. To actually make progress on the request, someone or some group of people need to step up and start a prototype implementation. They do not need to be Node collaborators. It could be anyone who are willing to invest their time in their work. Typically, they would create a fork, either as a personal fork or as a fork under the Node organization, and they will hack together an initial implementation, then send a pull request back to the main repository against the master branch. At these stages, there may be objections coming from collaborators or the community. Sometimes the proposal just gets stalled and closed. For example, this is the current status of the feature request for web crypto. Sometimes, but rarely, there are no objections, or these objections get resolved either through discussion or through voting. Either way, someone must be interested enough in this feature to get it through the consensus-seeking model. Then the initial implementation may get merged into the master branch. So once the feature is merged in master, we'll start iterating on this, fixing bugs, optimizing the implementation. At a certain point, depending on how feasible it is, we may start incorporating the subset of web platform tests for it, and collaborate with the web platform test upstream, as well as the specification authors to improve the spec and the test suite. It is also typical to eventually expose these interfaces to the global object, but this is not mandatory and depends on various complexities. At this phase, the feature is still in experimental status. Depending on the release schedule, this feature may be released to users while it is experimental, and it may get updated in the release branch with patches backported from the master branch. So this is the current status of web workers and the performance timing API. Eventually, this feature would be, or it is supposed to be, moved out of experiment and becomes a stable feature. This is the current status of the URL and encoding implementation. So here's a quick summary. Node Core APIs have diverged from the web APIs because they were designed for very different use cases. But more and more web APIs have now been added into Node Core. We have walked through the existing web APIs in Node Core and their status. Then we looked into the challenges and the workflow of bringing more APIs into Node Core in the future. So finally, we are starting an open standards initiative in Node to collaborate more with standards and other implementations. As we have talked about earlier, there are still many open questions to answer, and it takes a lot of energy to figure out the solutions. So if you are interested, please get involved. Okay, thank you.